Here we are solving October 2023 Pure Math 3 paper. In the previous two videos we looked at question number 1 to 7. Now let's start with question number 8, part A. Prove that 2 cosecant square 2 theta times 1 minus cos 2 theta is equal to 1 plus tan square 2 theta. So for this type of questions you need to take only one side of the equation. I'm going to start from the left hand side. 2 cosecant square theta, okay, keep 2 here, 1 minus cos 2 theta. Cosecant square is 1 over sine square, so I'm going to put it as sine square 2 theta. We know this identity, the double angle formula, sine 2x is 2 sine x cos x. So when we square both sides, sine square 2 theta becomes, okay, sine square 2 theta becomes 4 sine square theta cos square theta. On top, open the bracket, you will get 2 minus 2 cos 2 theta. The next step, keep the denominator as it is, 4 sine square times cos square, 2 minus 2 times, use the double angle formula for cos 2 theta, which is 1 minus 2 sine square theta. And then open the bracket again, take minus 2 and multiply both, you will get 2 minus 2 plus 4 sine square divided by 4 sine square cos square. You can cancel this 2 and 2, so it's going to be 4 sine square over 4 sine square cos square. Can cancel 4 sine square, so you are left with 1 over cos square is secant square, and we know this identity, secant square minus tan square is 1, so secant square is same as 1 plus tan square, which is equal to RHS. That's all, hence proved. It's a easy 4-mark question, but you need to know this double angle formula, sine 2x and then this cos 2x and then secant square minus tan square is equal to 1. You need to know these identities in order to solve this. Let's move on to part B of the question. Solving trigonometric equation. Okay, in part A, we have rewritten this in the form of, if you look at part A, we have rewritten this in the form of 1 plus tan square. So here you can write it as 1 plus tan square x is equal to 4 plus 3 secant x. 1 plus tan square is secant square. So secant square minus 3 secant x minus 4 is equal to 0, which is basically secant x minus 4 times secant x plus 1 is equal to 0. You will get two solutions. Secant x is equal to 4, secant x is equal to negative 1. Flip both sides. So cos x is going to be 1 over 4. Cos x is going to be negative 1. If you look at the cosine graph, this is 90, 180. Cos will be negative 1 at 180 and then 270, 360. This is the graph from 0 to 360. So we have a solution 180 degree here. But the question clearly says x is not equal to 90n. That means x cannot be a multiple of 90. So this is not a solution. So just write it as no solution key. Now we need to solve this equation. Cos x is equal to 1 over 4 in this interval 0 to 360. Cos x is equal to 1 over 4. The limit is 0 to 360. They want the answer to one decimal place. First find the principal value. Cos inverse of 1 over 4. Use degree mode. Cos inverse of 1 over 4. 75.522. I'm gonna store the value as a 75.522. That's not the solution, that's a principal value. Now use the CAS diagram, the ASTC diagram. From 0 to 360, look for the quadrant where cos theta is positive, which is here and here. So the angle is theta here, 360 minus theta here. Theta is a principal value. They want the answer to 1 decimal place, 75.5 degree. And then 360 minus theta. 360 minus, I stored the value as A. 284.5. 284.5 degree. They want the answer to 1 decimal place. That's it. Question number 9 now. We have a figure given. Let's read the question. Figure 2 shows the sketch of the curve with the equation y is equal to 2 minus 4 ln x plus 1, where x is greater than k. So before you read all this thing, just look at the figure first. Here is the figure given. You need to understand the figure. They're talking about, usually log x will be something like this, right? Log x. And if you replace ln x, if you replace x by x plus 1, we are going to move the graph to the left side. To the left side 1 unit. So the asymptote at y will be moved to the left side. So this is supposed to be -1. But we will double check. How do we double check? This ln cannot be 0 or a negative number, right? So if it is 0, x is equal to -1. If x is any other number smaller than -1, let's say x is -2, you plug in here, this becomes negative. That's not possible. Ln cannot be negative also, right? So that tells us x should be, the value of x should be greater than -1. So what's value of k? K is equal to -1. That's just a 1 mark question. Part B, find the y coordinate of a x coordinate of b. Basically they want you to find the x-intercept and y-intercept of this function. We have a function y is equal to 2 minus modulus 2 minus 4 ln x plus 1. To find the y-intercept, we replace x by 0. So when you replace x by 0, y is equal to 2 minus 4 ln 1. And we know logarithm of 1 or natural logarithm of 1 is 0. So this whole thing becomes 0. Modulus of 2 is 2. So the y coordinate of a, or you can just write 0, 2. And for b, to find the x coordinate, we replace y by 0. So in this function, y is equal to modulus 2 minus 4 ln x plus 1. We need to replace y by 0. So you will get 2 minus, you don't need to take positive or negative argument because this is 0. So you take positive or negative argument, you will get the same answer anyway. 4 ln x plus 1. Make x as a subject. So ln x plus 1 would be 2 divided by 4 is half. Remove ln, the other side becomes e power half. So x is equal to e power half minus 1. So the point B is e power half minus 1 comma 0. The x coordinate is just e power half minus 1. Let's move on to the next part of the question. Part C, they want you to solve this inequality. Okay, again I'm going to go back to the curve. We have this curve. Now let's draw the line y is equal to 3. Okay, here if you draw the line y is equal to 3, since this point is 2, the 3 should be above this. We don't know whether it's here or here. Okay, so we don't know whether the line is intersecting the curve with 1 point or 2 points. So you need to take the positive argument and negative argument separately and solve it. So I'm gonna find the point of intersection in order to solve this inequality. So I'm gonna take the positive argument, 2 minus 4 ln x plus 1 is equal to 3. And then the negative argument, minus 2 minus 4 ln x plus 1 is equal to 3, and solve them separately. So here you will get 3 minus 2 is 1 ln x plus 1 is equal to -1 over 4. And then make x as a subject, you will get x plus 1 is e to the power -1 over 4. When you get rid of the logarithm, x is e power -1 over 4 minus 1. The minus 1 is not in the power. And then here 2 minus ln 2 minus you can open the bracket, minus 2 plus 4 ln x plus 1 is equal to 3. Minus 2 goes to the other side, plus 2. 3 plus 2 is 5. ln x plus 1 is equal to 5 over 4. So when you make x as a subject, you'll get e to the power 5 over 4 minus 1. So basically there are 2 points of intersection. So the line should be somewhere here. You have 2 points of intersection. This x value would be a negative 1, this would be a positive 1. So now since we have 2 points, we need to use our calculator to find which one is a positive value, which one is a negative value. We have the 2 points here, e power minus half minus 1, e power minus 1 over 4 minus 1, e power 5 over 4 minus 1. I'm going to use my calculator to check which one is a positive and which one is a negative value. E to the power minus 1 over 4 minus 1 is a negative number. Okay, if I put 5 over 4, I get a positive number. That means this point is e power minus 1 over 4 minus 1. This point actually, the x value, x coordinate of this point of intersection is e power 5 over 4 minus 1. They want us to solve this inequality. 2 minus modulus of 2 minus this is greater than 3. So in the graph, the modulus graph should be above the line y is equal to 3. So what you first need to do, you need to divide the graph through the point of intersection. You have 3 regions, region 1, 2 and 3 regions, and find out in which region the modulus graph is above the straight line. So it's in here above the straight line, here also above the straight line. So you need to take only region 1 and 2. In region 1, the solution is, don't just put x is less than this because the graph ends here. So between these two. So 1 is less than x is less than e power minus 1 over 4 minus 1. Or in region 3, all these values. X is greater than e power 5 over 4 minus 1. That's how you solve the inequality. So remember this, whenever you get inequality, you solve it like a normal equation. Find the point of intersection, divide the graph through the point of intersection into few regions, and find out which region satisfy the inequality. Take the corresponding x values. Question number 10 now. A curve C has equation x is equal to sine square 4y. The point P with x coordinate 1 over 4 lies on the curve. They want you to find the y coordinate. If you know the x coordinate, just sub in into the function to find the y coordinate. Here replace x by 1 over 4. You will get 1 over 4 is equal to sine square 4y. So sine 4y is square root of 1 over 4. We will take only the positive 1 over 2. And then 4y is equal to sine inverse of 1 over 2. I'm going to use the degree mode. Sine inverse of 1 over 2 is pi over 6. So from here we will find y is equal to pi over 24. That's all. It's a 2 mark question. Let's move on to the next part now. Find dx by dy. We have x is equal to sine square 4y, or you can take it as sine 4y whole square. You don't need to write it, just consider it as sine 4y whole square. When you differentiate, we need to apply the chain rule by taking this as x. So we have x squared, derivative of x square is 2x times. Now we need to differentiate the highlighted one. Derivative of sine 4y is 4 cos 4y. So it's going to be 8 sine 4y cos 4y. Don't apply any trigonometric identities or anything. Just leave it as it is. That's dx by dy. Let's move on to part C of the question. We got dx by dy in the previous part. dx by dy was 8 sine 4y cos 4y. They want you to find dy by dx in this format. So dy by dx is, you just need to flip both sides. You will get 1 over 8 sine 4y cos 4y. Okay, the original function was x is equal to sine square 4y. Wait, was it sine square 4y? Yes, sine square 4y. So sine 4y will be square root of x. Square root of x is sine 4y. So we can replace this sine 4y by square root of x. And then if x, how do we find cos 4y? Cos square 4y is, we know cos square is 1 minus sine square. So 1 minus x, because sine square 4y is x. So cos 4y is going to be, square root of 1 minus x. So we are going to sub in here. So we'll get 1 over 8 square root of x square root of 1 minus x. Now we need to write this in this format, and this question got only 3 marks actually. By right you should be given at least 4 or 5 marks for this question, but you are given only 3 marks because we are going to apply completing the square to write it in that form. So we got dy over dx is equal to 1 over 8 square root of x square root of 1 minus x, but they want the answer in this format. Dy over dx is equal to square root of q plus square root of q plus r times x plus s whole square, 1 divided by everything. So what I'm going to do, there is no number outside the square root. So what I'm going to do, I'm going to bring 8 inside the square root. We can write 8 as square root of 64. And combine everything to a single square root. You will get 64x times 1 minus x. Bring x inside. You get 1 over. You see what I'm going to do? I'm going to take negative sign outside and then multiply by x. You will get x square minus x. Hope you guys understand this thing. And then I'm going to apply completing the square. 1 over square root of minus 64. X square minus x. Coefficient of x is 1. So half of 1, which is 1 over 2. So 1 over 2 whole square minus 1 over 2 whole square. You should know how to apply completing the square. And then you can combine the first 3 terms as x minus half whole square. And then minus, this becomes 1 over 4. And you have negative 64 outside, everything inside square root. Hope you guys understand this step. Now I'm going to take minus 64 and multiply both. So minus 64 times minus 1 over 4, you will get 64 by 4 is 16 minus 64 times x minus half whole square. That's all. If you want, you can write separately. Q is equal to 16, R is equal to minus 64, S is equal to minus half. Even you don't write this, you will be given full marks. It's just a 3-mark question. So much of working actually. That's all. Let's move on to the last part of the question. Using your answer to part C, state the x coordinate of the point where dy by dx is minimum. So when you read the question, don't think about the turning point or stationary point or maximum, local maximum, local minimum. Dy by dx, consider this as just a function. 1 over square root of 16 minus 64 x minus half whole square. If you read the question, the value of the x is between 0 to 1. So the value of the x is from 0 to 1. So for all these values of x, you will have different values of dy by dx, right? But think about it, when you sub in x is equal to 0 here, you will get negative 64 times 1 over 4, and then you will get, I think, 1 or something, right? So this dy by dx will be minimum. This dy by dx is a fraction which will be minimum if the denominator is maximum. The denominator has to take a maximum value. When it takes a maximum value, you are subtracting a number from 16. The number you are subtracting must be a smaller number, right? So in order for this to be a smaller number, x has to be half actually, because if you sub in x is half here, this becomes 0, the whole thing becomes 0. You sub in any other value in the place of x between 0 to 1. You take any other value between 0 to 1 and sub in the place of x. You will have some number here. You will have some number here. So when you subtract the number from 16, it will become smaller. The denominator becomes smaller. So that's why the x is equal to half is the answer. So when x takes 1 over 2, when x takes 1 over 2, when you sub in 1 over 2 here, this whole thing becomes 0. You will get 1 over square root of 16, which is 1 over 4. That is the minimum value of the dy by dx. So that's the answer for double I. So here the answer is x is equal to half. Here the answer is dy by dx is equal to 1 over 4. That's all.